Hey, so I wanted to show you a video on how to break down a series circuit. And this is kind of the method I use. And so I'm going to start here and just tell you that my total voltage, we'll say, is 9.2 volts. And so we look at this, and I start with this template. A couple of things that I have out here are my calculator. Behind me, I have my series circuit formulas that I'm going to be using. And then I also have this guy here. And this is, I call this my slide chart. And I have the kids kind of use this to figure out how to convert back and forth between units. So I'll kind of quickly also show you how to use this guy in conjunction with the other stuff. All right, so let's start here, and I look here, and I start with this guy. Okay. So first thing we're gonna do is fill out our knows and our need to knows. Well, we have our voltage total, and we know that that is 9.2. We know our resistance at each resistor, so I can come across here and I can say R1 is 330. R2 is 1 kilo ohm, and I'm going to go ahead and convert that right into a base unit here. So that's 1,000, and then 470. Okay, so I'm gonna do that. Now I'm going to say, okay, well, what else? Is there anything else that I can ascertain from the information that I've been given? And there's nothing else that I can then put out here. So that's kind of, so step one then is going to be to find my resistance total, because that's what I can do next. So if I'm kind of taking a note about what I'm doing, I'm going to say step, and I'm going to say one is to find the RT. Okay, so I'm gonna do that by adding those up. Once again, I can look at my formula, and in a series, my resistance is just a sum of the parts. Okay, so remember that I had to transform base unit. And we see that that is 1,800. Okay, so now once I do that, now what can I do? And I can say, oh, I can use Ohm's law to find the current total. So step two is going to be find the current total. And I'll make a note here using ohms. Okay, so I don't have that. Well, we can do the triangle real quick, and I can kind of draw that. I need to put that on here. So when I look back over here, here's my Ohm's law triangle. I've got my voltage and I've got my resistance, and I want to find my current. So voltage divided by resistance is going to give me current. Once again, got to make sure I'm in my base units. 9.2 divided by 1,800. And the way you always say, does this make sense? Is I should get a small number. Current is typically, for all the circuits we work in class, is going to be the smallest value. And so you can see that it gives me a very small value. And so I can write that down here. 0.005, and we'll keep a couple of those ones. And if you're struggling, if your kids struggle, what I do is when I have them use this is I say, okay, here's your decimal point, and we just go in groups of 3. So if you would just write that number right above here, so 0.00511, and I'm going to say, okay, so what am I using? Where did that number start? Well, it started in milli. So I could rewrite this number as, I could rewrite that number as 5.1 milliamps. And that helps them slide that around. Okay. So if just to kind of show you how that works. So I've got that current written down. Now, my next thing is I'm going to say, okay, well, what can I do next? Well, let's look at our rules about current in a series. And what we see is that our current is always the same in series. So if I know the total, then the current at each resistor has to be the same. So I can come along there and I can write that 0.005 0.0511 down at each place. My pencil's getting a little bit dull. And that would be in amps. If you wanted to have them show their units, these would all be ohms, right? Which is a good practice to get into. This would all be in amps. All right. So next is, what can I do next? Well, so let me say, so 3 is to find current at each resistor. Okay. Step 4, use Ohm's law triangle, IR, to find voltage at resistor 1 through resistor 3 in this case. So that's kind of step 4. So now I look here and I go, okay, well, let's look back at my Ohm's law. So if voltage is what I want, I multiply I times R. So I come across here and I just go, boom. Let's go 330 times 0.00511, and we'll call this, equals, 1.68. I'll do the next one, 1,000. And some of you are already ahead of me on this one. That's okay. 5.11. I'm going to do the same thing here. 470 times 0.00511. And we get 2.40. Now, I've got all my blanks filled in, but I've got one last thing to do, and that is I want to verify using Kirchhoff's voltage law, which says that the sum of the voltage drops is equal to the total. Okay, so the sum of the parts is equal to the whole. So what I want to do is I want to take these 3 voltages, I want to add them together, and they should equal close to that. Use Kirchhoff's voltage law to discount double check. So I've got 1.68 plus 5.11 plus 2.4 equals 9.19. That's close to 9.2, and we're done.